All right, well, welcome everyone. My name is Giori, and I work at Mozilla, which is a great place. If you don't know, it's got a nonprofit foundation mission to keep the web open and accessible for all, put the people first. So my talk really is about, I'm on the Mozilla IoT team, applying that mission to put people ahead of technology, put the mission to make people's lives better first. And so not all of the things I'm talking about are necessarily applicable to an enterprise IoT situation or other use cases, but specific to a smart home and the privacy and security for individuals are the kinds of analyses I'll be doing in the talk. And then the second half, I'm going to be going through a live demo of what does it mean to put people first. So first I'll talk about some of the technology challenges we have in IoT. And instead of IoT, I should be saying WOT, only people don't know that acronym so well. But at Mozilla, we're pushing for the web of things, where web basically is an interoperability layer at like a JSON schema on top that sits above all the IoT device data. So the concerns, again, just caveating this talk that I'm looking into, is the people's concerns. If you have a smart home and you have all of these connected devices, I don't want hackers logging in and seeing what's going on in my home network any more than I want them to grab one of my embedded Linux platforms to make attacks on the outside, like that myriad bot hack. On the privacy side, the biggest problem I see is that all of these data are just automatically being sent to the cloud. What's the user's choice in not having them sent to the cloud? So all those habits going up there knows, tells when I'm home or not, feels creepy, and so not just device data, but listening devices stuff, it's all creepy. But you want some of the benefits, right? So another aspect is the interoperability. Most consumers can't figure out what goes with what. What can I plug in? Can I do this? Can I do that? And are they both just, I manage the device itself, or can I actually trigger this button to turn on that light? So those are the types of things we're looking for. And then overall value. We want to make people have better lives. And some of us would just play around with it because it's fun, but really the ultimate objective here is to make people's lives better. So I'm not going to go too much into the survey, but I did do a survey of a couple hundred users of people that are using our Web Things Gateway and Firefox users that just randomly submitted to a survey. And of the people that have smart home devices, you can see that smart home assistance was number 2 overall. It was number 1 of the Firefox users, but the Web Things users had a lot of smart devices already. And then when people have never used a smart assistant before, they don't have one, voice is way down there on their list of ways they would want to interact to turn on lights and so forth. But if they do have a smart assistant already, they really like it. And I admit I'm hooked on the voice. I don't use commercial smart assistants, but I use the private local smart assistant capability we have with the Web Things Gateway. And it's addicting. It's really fun. And the other aspect of this is that if you didn't have a smart assistant, over 75% would only use something like that if it was private, local to them. And that dropped significantly of the people who had used a smart assistant. They were already willing to give up some privacy if they trust the company or if it used an existing smart assistant. That was kind of an interesting thing. So now I'm going to go into my 7 habits that some of which just don't work for us on the smart home use case. And the number 1 thing is all these devices that talk immediately to the cloud. You get all these silos. The user can't choose to do interoperability things between the two. The complexity is up there. Privacy is down. And then the current one interop style is works with. And so, it's all interoperable through my Alexa or through my Google Home. Problem with that, I see it, is that data of the brand of the device is in their cloud, and then in order to use at least Google and Amazon, you have to have a copy of that device state and data also with Google and Amazon. So like the power in the hands of too few is the way I see it. And you still, even though you get some automation with voice, you still have to have your apps and details to set up, do the detailed stuff. Standards in general are good. I agree with them. And all we need from standards-based IoT alliances is to bring that data one layer higher to the web. Right now, the way we do that is we bridge Zigbee, Z-Wave devices to the web. Bluetooth and Wi-Fi don't really have descriptions, so they need a little further to go. So bring them up one level higher. The other works with style is just with a brand. Consumers get confused. You know, the SmartThings Philips Hue integration requires you to still use the Philips Hue bridge, so you still end up with 2 hubs, right? It doesn't make any sense. IoT as a service, again, great for enterprise use case or business or organizational use cases, but there's just a factor of privacy is that do we want all this data sent up there? No, they should be used for business and industrial use cases and not necessarily all our smart home data going up there. Plus some of these cloud services that have been offered to developers like Arctic they go away, and then what do you do? And they tend to be all different. So you get locked into them. Easily send the data to the cloud is another scary thing to me when you're talking about smart homes. And we like the JSON schema thing, but that's the Web of Things schema. So transports like MQTT don't take it quite far enough. It's good transport. Needs to go one step higher. And then the tailored, customized IoT solutions, anyone offers you full flexibility. Again, it brings me into these are great companies, they do great things, but they should put a little more emphasis of when they work with that company to say, hey, can we bring your data to the standard of the web and not just leave it at the standard of your company or the API of your company? So in a nutshell, what I found is all of these IoT marketing spiels all end up with like custom APIs and custom data sets that don't make things easily interoperable. So I tried to describe a few of the differences. If we could, instead of works with certain things, works with the web. That's ultimately what we're trying to do here is works with the web. And then web application developers everywhere can use these data. So the forecast of Mozilla Web Things is sunny and clear rather than cloudy like the rest of these. And how do we do that? Right now, our approach is we've got just Web Things Gateway that runs on a Raspberry Pi, runs on a Turris Omnia in terms of downloadable images, and you can also just install it on a Linux or a Mac platform. The frameworks are open source libraries that allow you to bring data from Arduino or Python, MicroPython, or Rust, or all these languages and have Web Things libraries. Microblocks is one of my favorites that I teach kids with. And so you bring all of that device data to the web. And then the main difference for our smart home approach is that data stays in your home on an always-on box that manages your smart home, and your voice interactions, your data interactions are all there. Yes, you'll have encrypted backups eventually in a commercial sense to store your configurations and backups. And because it's web data, you don't need a special app, you just need a web browser instead of all your data going to the cloud and you having an app per different device. So gateway, smart stuff, we can already have add-ons to a lot of commercial stuff, and then it's just consumer privacy, manage your own home. And the way we do that in terms of privacy, we have 3 pillars: privacy, security, and interoperability. Privacy is it stays in your home. Security is the first thing you do is set up a subdomain off of MozillaIoT.org, and if you use our subdomain off of this, we'll automatically install the Let's Encrypt certificate onto your Raspberry Pi, onto your Turris Omnia. We do that automatically for you if you use our images. And a third pillar being interoperability says it doesn't matter what the transports or the data sets look like or the buses. You just got to get IP to connected device layer eventually, which allows you to bring it to the web. Everything we do is open source at Mozilla-IoT on GitHub. We have public IRC channels and public discourse channels and email address and issues on GitHub. And a lot of the community participation is on the add-on side. So we have some just great add-on contributors of bridging different commercial devices. So we have this example adapter there. You can look at that and it's like, oh, I bought this device. How do I tie it into my Mozilla gateway? So the ultimate consumer value proposition is you buy the box, it's yours, it's your data. That data, when you want to share it, it's up to you. And interoperability across vendors. So I'm going to jump here to a live demo, and just as a backup or for people who aren't here, I have a couple of just brief YouTube videos of stuff sitting on my desk. Start here with this is W3C web interop. We actually do this for online plug fests and things with the W3C Web of Things organization that we work with. So I was just going to add a couple of virtual things here. Let me get rid of the on-off. That's redundant. This, and then maybe a pulse, a couple of pulses. So this is how you would, when you plug in a device like Zigbee or something like that, or Wi-Fi, and you have the right add-on, it discovers those devices automatically. And based on those discoveries, here's my house. I have a motion sensor, a door sensor, and some smart plugs. Behind these are details of the web. This is a JSON format structure. This is the standard Web of Things. And this is just a visual representation of it. So the coolest thing of interoperability is rules. And so I'm just going to create a rule here. Let's see, what rule should I do? Let's see, how about if there's motion detected or the door is on, or I click my little pulse for 5 seconds. So if this is on, if this is open, if motion is sensed, and I have it, or how about let's do while instead of if, and then or. Instead of all of them, let's say or, because I can't actually affect the motion in the door, but I can click on the pulse. And if that happens, we're going to turn the virtual color light to, let's see, a different color like red, and then turn on the smart plug. And then I can just say, just say test. So now we have our things for our rule, and you can edit your rule. And so now I can't affect these two things, but I can click this pulse 5 and turn the light to red and turn on the plug. So now let me show you some more real things. This is the Turris Omnia installation, and I'm going to use it to show you some of the settings parts of the menu. First of all, that Let's Encrypt domain, you pick that subdomain. I often like to make the local network match that. On the network settings of the router, you have the WAN side. On the Raspberry Pi, you'll only see the LAN, or the Ethernet or the Wi-Fi settings. Users, you can add as many users as you want. Right now, we don't have user privileges yet. Add-ons is the key thing. This is where the community comes in. And as I scroll through this list, look at the buy and the license. So far, they're all open source licenses, but they're by all these different people in the community. There's some really prolific add-on writers out there, and they've done some wonderful things. And they're add-ons not just for physical devices, but also for service things like notifications and bringing data in that you might want to take actions based on external information. So you'll see a lot of different stuff in here, weather data. I'm just going to scroll through here. When you get all the way to the bottom, you'll see the Zigbee and Z-Wave stuff, which I think is probably some of the most common of the protocols that have to be translated into web things. So this particular Turris Omnia has just one smart plug added to it. And then we do quarterly releases of the gateway software, so the updates will happen automatically on the Raspberry Pi, and after the next Turris Omnia, we're working with that company, Turris, to do their Turris OS updates for them. The authorizations I want to show you really quick. I've got both the experiments on. The authorizations, what happens is now that you have data at the web, we have an example here to show you, let's let somebody monitor the the Samsung light and button and maybe the weather or whatever. You click allow, and it creates the JSON token, and it even shows you developer style examples of how to use that token. Now you can set up a web service anywhere you want, and you can exchange those data. And because I did that, now I would have a web token. Okay, I'm going to cut over to my house and just show you some of these other things like weather. That's coming in from just me putting in a latitude, longitude. I'm following the tide in Redwood City. I've got the date time adapter, which is really handy for different rules. So I can do things based on sunset and sunrise and every minute, you know, so sometimes you want to do stuff like that. You can see also I have a camera. I don't have any pointing inside my house, but I can open the snapshot and see that EA verily no one has stolen the car sitting in the driveway. So that's good. Let's see, and I also like do things like the button has a temperature associated with this Samsung SmartThings button. And then I just want to show you a little bit about logs, where basically logs say, I can look here and say, oh, it was around 7 o'clock when the door opened when my husband left the house this morning. No one's been in the house since, at least through that door. This is a light that automatically goes on and off to make it look like someone's home. I can see when the fan, I have a fan set up to automatically go off at like 4 a.m. if it's to cool the house. I monitor those earthquakes. This is the magnitude. This is the distance from my house. This is the temperature inside that Samsung SmartThings button. And that little blip is where the sun hits it in the window in the morning. And then it gets direct sun, and then the sun passes past the window, and then it cools off. And you can see, like last night, it looks like my husband didn't open the windows downstairs, and or it didn't get as cold at night. So here's the internet temperature I'm pulling every minute or every hour maybe. And then again, I care about tides in Redwood City because that's where I row. So anyway, you can see it's a combination of data you're pulling from the internet, data that you're producing locally. If it's raining, don't sprinkle, all those kinds of things. And then, let's see, some of the things I do, look at San Francisco has an active earthquake. This is pulled from USGS. Little Lakes, while I was setting up, this exact location had a 4.5 triggered. So there was a little bit bigger one. I mean, still, if you're in that region, you can feel it. This was a 1.5, so it's kind of an aftershock. That's why it still occurred. These are a bunch of IKEA lights I have in San Francisco. Again, I have a camera that I can turn to look at more of the lights near a couch and stuff like that, but I'm going to skip that instead and go to my office desk, which is more fun. So sitting on my desk, I have some stuff that I like to teach to kids. And so these LED strips here are, in fact, let's start the video. So this is going to be a video of my desk, and we're going to annoy the people who are sitting around my desk just a little bit once I get this set up. I tried not to practice things too much. So you might hear some background music because there's a web camera sitting there, and I'm feeding the audio through my laptop. So what I'm going to do here is turn on these lights, turn on the heart rate, and you'll see the heart rate monitor start out. When it first goes on, it's going to be down at a heart rate of 67 beats per minute. And normally this example on that little microbit is it reads the heart rate, but I modified the Web of Things library of the package so that I could set it instead. It doesn't like being set so well, but I'm going to jump it up so you can see the heart rate. The LEDs, let me zoom in here. The LEDs went on. The heart rate is low. I can jump over here and turn them to red, and then rainbow, and then turn everything off. So you see the heart rate zoomed up, heart rate is going up. This is just through a USB serial library, but you can do it over Wi-Fi, Bluetooth, any technology. And then you see the LEDs on the top change to red and rainbow, and then everything goes off. Okay, so that's one Raspberry Pi that's just handling make my own things. And then I have another Raspberry Pi where here it gets a little bit more crazy with me annoying my party flatmates, whatever. So I'm going to do this test. This is a test warning that will go out and say, hey, I'm about to, don't be alarmed, I'm about to do stuff. And then I'm going to turn on party mode. And I might just grab my phone. I can do the same things here.
Do not be alarmed. This is a remote test.
Okay, so then we're going to get party mode. And then we're going to, I'm going to do through the internet. I don't know if you can hear the music. It's playing off this Sonos, it's a IKEA Symphonist Sonos speaker plus thing, and we're going to turn, let's just use this, turn the volume up, set the volume to 50%. And so we'll hear the volume go up. I can change the color of some of these lights. Pulse red. And then I'll probably turn the music thing off. So you can hear I turn up the volume. And it's a jazz station. It's just an internet streamed station to it. And then I turn that off. I pulse the colors to red. I can actually make them do all sorts of different colors, like blue, and then red, and then rainbow. And then one of the coolest things then is I use the Google Home use the Google Home to speak, to turn the local voice controller to turn things off. Oh, so you can. So all these things.
Hey, Snip, wait for beep. Turn everything off.
So I literally used the voice of the Google Home. It said, hey, Snips, and I had to put in a pause, wait for beep, because the Snips has a beep. But that little, this little speaker microphone is just plugged into the it's a little Jabra speaker mic. It's just plugged into the Raspberry Pi's USB port, and we use these Snips open source libraries that detect the wake word. In fact, I'll show you the video, or the voice controller, so you can see that it detected that. So it detected the wake word, and it detected my speech, and then it interpreted beep as please, probably. Turn everything off, and you can see in my test sometimes it detects the please and sometimes not. It just depends on the background music and everything. But so this is my way of essentially showing you a private, local processed voice command, even if my voice isn't there. And you can also do things through a browser, so I can say, turn on the kitchen. And it says, okay, turning the kitchen on. And it shows you, this is part of the Smart Assistant, you know, turn on the kitchen, turning the kitchen on. And I can also type turn off the kitchen. And so if you say something and it doesn't understand it, you can see what it thinks you said. So that's the demo side of this thing. In order to save, I have about 10 minutes for questions, and I have a whole bunch of backup slides. So I'm just going to go back to thanking you all from, in addition to thanking you all, I want to thank the Mozilla IoT team and the community that's been contributing to this project. It got started by Mozilla before I got there, and my background in Wi-Fi routers and things is luckily landed me there because it's a great place to be as a company. So there's rock stars in the community and the team that's been developing it. And ultimately, we're doing it for people like you and me. So I hope you get a chance to go to iot.mozilla.org and give it a try. It's really not hard to set up a router. If you have any questions, like I'll even walk you through it over a conference call. It's not hard. So thank you for coming, and tell all your friends to watch the video if they couldn't get here. Thanks. So does anyone have any questions? Denny. Yeah, so the browser processing is being processed by Google, I think, at the moment. Mozilla has a deep speech project that we might be able to tie it into the deep speech project. And there are other, basically, through the browser, what I see is the person would be able to configure when it goes to the internet, when they're not home, what to connect it to on the back end. We also have a Mycroft skill that was done, and that should be published soon. And so, we want people to have choices for smart assistants. And, again, one of the best choices is just being able to make it completely private if you do want it completely private. So. But the browser-based, yeah. But it could be that the browser-based voice could be sent to your home, just like when I'm pulling these web user interfaces and from my phone and everything. This is being served up by the Raspberry Pi or by the Turris Omnia, and so the voice could be processed locally if it's a voice command that fits with these names. Basically, the language model is dynamically updated with the names of the things I give it. So I have this funky thing called colorizer, so that when I turn the colorizer red, I have a rule that changes other things to go red, or maybe that was the wrong red. Yeah, I used the voice one. And colorizer is not a word, but because it's a name there that gets updated in the language model, then it will be parsed. So you can test those things by just saying, set the colorizer to blue, and it will do that. Other questions? Has anybody heard of this project before they got here? 1, 2, 3, good. Anyone running a Web Things gateway yet in their house? I run several in different locations. And I just have to put in another plug for education. The other beauty of being able to work on stuff that's open is as a volunteer and sometimes part of work, we're teaching kids how to make these devices using this program called microblocks. So if you have kids, tell them about microblocks. Tell them to go to microblocks.fun, because in here, you can just go and pop up, and there's the Mozilla's Web of Things library is right in there, and you can define things with the standard with the standard schema, the JSON format. So behind the scenes, you say, oh, this is an on-off switch or a sensor or an actuator, and if it's a light, then it has an on-off capability, and you tie it to a variable. And you can even go in there, built into the IDE are examples, like that heart rate that was running on the microbit. There's an example here that I started from, and I copied this example, and then I added, instead of a number of the heart rate being set by me pushing the button, or I could change it to actually be sensed from a pulse meter. Instead, I changed it to an actuated variable from this list here, and so I could change it through the web user interface. But that's another great advantage of open source, no NDAs, licensing agreements, or stuff like that for education, is we want the rest of the world to be able to do this stuff without being beholden to paying for services, and all this data is private. So we've got some schools. One of the middle schools in San Francisco, one of the teachers has set up the Raspberry Pis on every single desk, and the kids get microbits and circuit playgrounds, and then they get to build this stuff, which I think is really cool. So if you have kids, microblocks.fun, it's a great way to make the things. And these little things right here, that ornament, that is a project that we do every Christmas in San Jose, Christmas in the Park. The disadvantaged schools in East San Jose get to program these seven LED things with it's Adafruit Itsy Bitsy on the back. And then we did a display last year where they were all controlled by Raspberry Pi, so their patterns could be synchronized with a whole bunch of them going on at the same time. And then others, they just put them on the Christmas trees and had them illuminating with their kids' own patterns. And they were programmed with microblocks. Any other questions? One there?
Motion sensor. Is there a certain threshold so that, for instance, it'll trigger a person passing through but not a leaf?
So the question is, a motion sensor trigger, what does it detect based on? That is completely dependent on the sensor. So you could make your own motion sensor, buy one of the sensor devices and tune it correctly. And I've played around with the delays and the expansion of what it sees. But typically when you buy them, like the IKEA motion sensor triggers for a full 60 seconds. And the Samsung one, I think the default is 15, but you can change it. So there are some knobs on motion sensors, but in general, they're pretty not that flexible when you buy them off the shelf.
Referring to more of how sensitive is it? So
How-
that it'll trigger on a person passing through, but not a leaf blowing by on the wind.
I think that, again, it's dependent on how it was built and how it was tuned, because I have this FOSCam thing. This is a OnVIF camera. There's an OnVIF adapter for these things. It has a built-in motion sensor and sound detector, and then it has like 5 levels you can set of detecting very, coarse or not so coarse, sensitive or not so sensitive. So you'd have to look at the package and the data sheets. They're variable. Okay, well, enjoy the rest of your time. Thanks again for coming.